Rapid shutdown devices were brought into our industry to prevent safety issues, is my understanding. So how is it that they're causing a worse situation to occur?
These small components can fail catastrophically and cause fires. That's ultimately the worst case scenario. A lot of companies out there don't really have process procedures in place and a standardization around QA/QC, and that's a big gap in the industry. There's no industry database.
Yeah.
It's very difficult to do something about it. We need to raise our standards for quality, safety, and reliability, and that takes, you have to have data. Without data, there's no way to act. We're trying to be the feedback loop to the industry. Hopefully other authorities can actually do something about it.
Hello and welcome back to The Future Current. I'm your host, Sean Swentek. I've got a special guest live in the studio with me today, David Penalva, CEO, founder of both SolarGrade and HelioVolta, two incredible companies in our industry doing amazing work. David, thanks for joining me today.
Thank you for having me.
Really excited to hear everything you've got to share. I know you've got a new report out, but just from the beginning, I think it's helpful for people to understand, what does SolarGrade do and what does HelioVolta do?
Great question. Yeah, HelioVolta is an engineering services company that is specialized in third-party quality assurance and quality control and field inspections. SolarGrade is a fieldwork management software application that helps companies to do data collection in the field, automated reporting, and do data analytics. HelioVolta uses SolarGrade for our daily work. So we have, our data, and we publish our reports based on data that HelioVolta has collected over the years.
Very cool. Now, my company, Omnidian, I know uses your services sometimes, and we have field technicians who provide O&M type services. Talk to me a little bit about what you provide that's different from like day-to-day O&M activities.
Yeah, so our perspective comes from having a more of a combination between engineering and field work.
Mm-hmm.
So our team members are all engineers with engineering backgrounds that understand deeply system design, standards, and code with field experience. And that's a very unique way of looking at systems. So again, that's one of the key differentiators.
Awesome. You're pretty famous in the industry for your SolarGrade PB health reports that you put out, and there's a recent report that was focused on RSDs. But can you provide just some top-level numbers from past reports that might be top of mind to that? I know, like, every time I hear some of these numbers, I'm amazed at what you guys uncover in the field.
Yeah, thank you. It's interesting, as we were part of a conference even this morning, they were talking about some of the insights that we already highlighted years ago,
Yep.
which again, I think if I pick some of the key data from our latest reports, you will say that this distribution has been unknown for many, many years until we kind of open up to the industry. That there's a lot of problems within the distribution. I think connectors and wire management and kind of the two big ticket items where we see a lot of projects having, I think 80% of projects that we inspect have connector and wire management issues.
80%.
Yeah, and along those lines, I think the last few years we've been noticing a spike on problems associated to RSDs. So we ended up like writing a paper about it.
And if I'm like a big institutional investor who's putting capital into big commercial projects, I may not even understand down to the level of but when we're talking about connectors and issues like that, what's the actual risk behind? I mean,
Yeah, these small components can fail catastrophically and cause fires. That's ultimately the worst case scenario.
and
So
it's something as simple as a little connector that's not
yeah,
done right. Wow, scary. Okay, I'm gonna jump into some questions that I prepared for today. David, you spent years inspecting solar systems that looked fine on paper, but were failing in the field. What is the most dangerous thing hiding in plain sight in a solar portfolio?
if we look at the specifically at issues, I would say again going back to the distribution.
Yeah.
I think the lack of standards or details around how you do wire management, how do you procure, connectors with the latest code cycles, really calling out the problem with the mismatch of connectors. There's a whole supply chain constraint. If you add on top of that the MLP's requirements, now you have to have 3 or 4 components that have to match connectors, and it becomes a little bit of a nightmare just to get everything right from the get-go.
It immediately makes me think of things like QA/QC, the golden row, things like this. Can you talk to me about the importance of that and your view on that?
Oh, that's critical. I think once you start implementing, so one of the first things that I tell everyone is that you cannot improve if you're not tracking your metrics.
Yes.
So QA/QC is all about like getting to know your numbers and understanding where are you falling short and improving the things that you need to do better. And I think a lot of companies out there don't really have process procedures in place and a standardization around QA/QC, and that's a big gap in the industry. That's
Yeah.
pretty wide. Like very few companies actually do have this in place.
And if a developer is considering QA/QC for a site, why not just use the EPC that built the system? Why should they come to someone like you?
Yeah, I think there is a conflict of interest on having the EPCs policing themselves.
Yeah.
And this been historically the way traditionally these contracts have been worked out. Well, no, we'll have a QA/QC team. There's always conflicts of interest internally to get the QA/QC to be the one leading the charge versus the schedule or the
Mhm.
budget, or so it's a lot of conflict of interest internally. What we see is good results when you externalize that function to a third party that is independent, to is giving you a perspective not only on how your company is doing, but also giving you data points against other companies in the industry. Are you doing better? Are you doing worse? Right?
Yeah, that data is critical, and again, avoids that sort of fox in the henhouse issue with having the EPC with that conflicted interest. What is the difference between a system that passes a standard inspection and then one that's really truly safe for the long run?
Yeah. I think is the standard inspections these days are really done by the authority having jurisdiction,
Mhm.
so the local authorities, and they're very, very limited in scope. They usually check the AC side of things. They really kind of do big ticket items. They really don't get into the nuts and bolts and the details. I think
Mhm.
our scope is way more detailed. We we really take an approach of sampling every single component that is on site. Sometimes you see defects of issues that are like crew specific. So the crew that you had on week 3 working on that side of the array actually was not following the process or was installing things incorrectly. So having a good methodology to assess quality for the whole site is key.
100%. Let's get into RSDs. Your latest report was really focused on rapid shutdown devices. I think your data said something like solar systems that have RSDs are 66% more likely to have critical safety issues. That's crazy to me. And like, how did you find that out? Like, what was behind that?
Yeah, so first you have to understand how we classify things,
Yeah.
right? From the risk severity point of view.
Yeah.
Anything that is critical or major, critical is an imminent risk to safety risk for personal or property.
Wow.
This is something you have to act right away. And major is something you have to do a track roll for. You cannot wait until the next preventive maintenance. That is the kind of criteria
Yeah.
behind this risk severity definition. When we put this data, is that you have to understand that adding more electronics, power electronics to the systems, add a lot of other potential issues with wire management. That is already a big challenge in the industry. Connectors, that is another big challenge. You're talking about doubling or tripling the number of connectors on site, which is insane.
And it's this whole thing is for people who look at our industry is probably crazy because rapid shutdown devices were brought into our industry to prevent safety issues, is my understanding. So how is it that they're causing a worse situation to occur when they're on a site? What's behind that?
Yeah, I think the intention with MLPs and rapid shutdowns was good. Like I think we need to protect first responders. We need
Mhm.
to protect firefighters. I think what we're surfacing is the data and the issues that we're seeing on site to feedback loop to the code making panel and the rest of authorities to do something about it, because I don't think these consequences, we call the paper in unintended consequences. These
Yeah.
are unintended
Yeah.
consequences. These are no one really wanted these devices to fail. I think we need to ask ourselves why. And I think we put in the paper a few clues on why. I think there's from defective products that are making it to the industry to insufficient standards, testing standards for those products. But if you look at the big picture and look at other countries, other markets, there's only requirements for rapid shutdowns in the US.
Yeah.
So that's
And for
typically one.
people who may not be as familiar, because you mentioned firefighter safety and first responders, why did RSDs become something in the market in the first place?
Yeah, so the code started with 2014, adding requirements to reduce the voltage. So the concern from the firefighter's perspective is that DC voltage is too high in the race. If they have to put a fire not related to the solar
Yeah.
system, the system is energized if the sun is out,
Yep.
right? So how do we protect the firefighters?
Yep.
So the code require to lower the voltage, within the array boundaries to a specific certain level, and that has been changing with the code cycles. Right now, I think voltage within 30 seconds have to be reduced to 80 volts. Going back to the why is because we wanted to protect first responders.
Mm-hmm.
There was never, it feels, we haven't seen data associated to incidents with firefighters getting shocked
Mm-hmm.
by solar systems. But because the industry was growing so fast, there was a fear that could have happened. And now we're seeing a lot more fires, at least from our data perspective, associated to these devices failing, causing a fire, and therefore the firefighters being exposed to risk with the solar systems that was probably unnecessary.
Unintended consequences,
Yeah.
indeed. Can you walk me through what a rooftop RSD failure actually looks like? What physically happens on the roof when that happens?
There are different potential root causes of that failure. Without getting into too much of the specifics, the devices will fail, and there are different ways that they can fail,
Mm-hmm.
but they will thermally fail. They get warmer or hotter, and at some point they fail catastrophically into thermal runaway, and they get really hot. And what happens in those cases is that if you have other cables next to it, they might create a loop for current to flow through, and then you just have DC arcing that cannot be stopped until the arc kind of extinguishes on its own, or it goes through the whole rooftop fire. So a lot of cases, they look like we have 3 different levels of incidents that we report in our report. The first one will be a malfunction, hot or abnormal temperature on the device itself. The second stage will be that is physically deformed, or there's very clear signs of melting, maybe a localized thermal event within the one solar module that is attached to. And the third one is a full catastrophic, structural fire on the roof.
So if I'm a system owner, especially if I'm like a corporation that has a building where like employees and customers are in the building at times, like I'm probably getting a little concerned as I hear this story. What are the steps I should be taking to like protect myself in our system?
That's a tricky question. Um, I think we put that in the paper as well, the owner's dilemma. Like,
Yeah.
what do you do about it, right? And if you think about it, the options that you have, you can get rid of them, but getting rid of them will put you out of the code compliance, which is a big no-no.
Yeah.
You are out of insurance. Like, there's a lot of consequences to that, so you wouldn't go that path.
Yep.
The other path would be you had a bad experience with one of the manufacturers. Let's swap all of them with a different manufacturer or a different solution. That's very costly. You have remediation cost, component cost, etc. The third option will be to try to retrofit the system to UL 3741, which is a section of the code that allows you to get rid of the MLPEs, but you have to make changes within the array, the placement of the inverters, and so on. Sometimes it's not feasible.
Mm-hmm.
We see a lot of companies going that route, but the fourth route is the real route that is everyone is facing, is that you just don't do anything until something happens, which is...
So I guess at that point, make sure you've got a really robust monitoring system in place and a provider that can identify that early, right?
Mhm.
Before it becomes catastrophic. Wow, scary. Um, you've identified since 2021, 21 unique cases of rooftop fires linked to RSDs. Why isn't that number getting more attention in our industry? That's a significant number of thermal events, as we call them, fires.
Yep. That's why we wanted to resurface that, because I think we have a unique perspective as a third party. We get to work with a lot of large companies, and we get to see their portfolios on some of these problems. But everything is under NDA. They don't really talk to each other. So we were like, okay, I think we need to get some data out without compromising our confidentiality agreements. So that was one. It's like, I don't think if there's no industry database,
Yeah.
it's very difficult to do something about it. But we felt the obligation to, bringing this up,
Yeah.
because in the end, I think the bigger consequences of these thermal events is that the public perception of solar being unsafe.
Mm-hmm.
And if you start seeing the general public feeling that having solar is equal to having a potential fire,
Yep.
no one will want to install solar, and that backfires against all of us. I mean, we're in here, we know this is a very safe technology. We need to raise our standards for quality, safety, and reliability, and that takes, you have to have data, and without data there's no way to act. So this, we're trying to be the feedback loop to the industry.
Yeah.
Hopefully it's helpful and informs the code panel, the making panel, other authorities that can actually do something about it.
Yeah, I mean, super helpful to us. I mean, our clients, IPPs and developers and investors, like this information is critical to them and they're grateful for it. This report's been out for a little while now. What has there been a response from these RSD manufacturers or other folks like that? Like, do they have any sort of solutions, answers? Has there been any feedback from them?
I think the the general feedback that I heard, and it hasn't been that many weeks, is being to put a lot of pressure on the installers. Like, oh, the installers are not installing our devices properly.
Mhm.
They're missing, and that's, there's some to that. It doesn't justify the components will combust
Yeah.
on their own, regardless if you install them properly
Right.
or not. I think the industry needs to do better on that regard. I
Yep.
agree. I think we need better QA/QC. I think now with
Mhm.
the big beautiful bill, we see a big shift to actually caring long term for these assets.
Yep.
So this has to change. We need to get better as an industry. We acknowledge that, but at the same time, we cannot have faulty products out there that are causing these huge problems.
Yep. I totally agree. What's the most common construction mistake that causes other problems beyond just RSDs that might cause serious problems for a system along the years of operation?
The most common construction problem that we see out there is not having a plan.
Mm.
I think that's what we see is, you know, there are two different, I would say, two different type of companies out there. There are the companies that are coming from doing a small commercial, large residential, that want to
Yep.
enter the commercial game,
Mhm.
that have literally nothing, no way. Like, they think that are in doing, oh yeah, this, we'll put it together in a couple of weeks, we're good to go. And it's kind of the Wild West.
Yep.
There's a lot of companies like that. There are the companies that are like playing with the bigger players out there, that there's still a big gap on, quality assurance and quality control within these companies. I
Yep.
think there's always a lot of pressure to get these projects on time. There's always some type of deadline.
Yeah.
There's so many factors that affect how the systems are built, that that's just the lower priority. For many years has been the lower priority.
Where does responsibility actually sit when a solar asset underperforms or fails? Is it the developer, the EPC, the owner? Like, how do they get to the bottom of that?
I think I will put it on the owners.
Yeah.
Like, I don't, like, if the owner doesn't push the bar,
Yeah.
no one else is gonna push for them.
Yeah.
So asset owners, if you want to own an asset, you bring your A game.
Yeah.
Otherwise, they're gonna trick you. No.
That's good. I think that's fair, and it's if you're gonna own assets, make sure you're owning them properly, I guess. What role should field inspection data be playing in how the industry writes its standards and codes?
I always say that you can only improve what you can measure.
Mhm.
For many years, the reason why I founded HelioVolta and SolarGrade was with safety, quality, and reliability in mind.
Yep.
Unfortunately, after spending, I've been in the industry for around 20 years. It was about 9 years ago when I got involved in, big thermal events for a really large company with a lot of nasty legal battle.
Mhm.
That's when I realized that solar was a stake. And I I ended up spending a lot of time in the field
Mhm.
working with the field techs. Very hard work. Like, being in the field in solar, you have to go on there to understand what it is.
Yeah.
Like, I think a lot of people that are in the solar industry haven't been on a solar site, and they don't know what a construction looks like,
Yep.
and what operations maintenance look like.
Mhm.
Once you get to the field, you realize, oh, that guy's telling you, he knows all this stuff. He knows what's wrong in this project. There are two main problems. One is that we don't give them the tools to be able to record that data and transfer that data to someone else that can make a decision.
Mhm.
And also, we lack the standards. So I'll give you an example. If you and I go to a site and we both find a problem,
Yeah.
I guarantee you'll classify that with a different risk severity than I do. just because of your experience in solar and my experience in solar, right? So we publish and socialize our internal methodology for risk severity. I think that's extremely key. The industry doesn't have, a standard. And if you have two different O&M companies in the field, they both will tell you what they think is a higher priority on the same issue, which is super interesting. And a lot of problems go unnoticed just because they didn't know better on how to transfer the information to the asset owner. If you are the asset owner and I'm telling you there's a high risk of something happening, I guarantee you want something to be done right away. It's just a lot of times that information doesn't bridge the gap.
Yep.
Again, going back to your original question, yeah, you have to have the data. You have to have being able to convey that data, and you needed the tools, and that's why we created SolarGrade with that goal in mind.
So, what if that other person with a different opinion on the severity, what if their response to you is, "Oh, you're fear-mongering," or "You're saying it's much riskier than it actually is." Like, what's your response to that?
Yeah, it's all. I'm an engineer, so the science fact basis. So we have like a full-on methodology that is public. That you want to challenge it. That we're kind of using that methodology, and it covers code, compliance with code, compliance with manufacturing specs, it, risk severity, frequency, etc. So
Yeah.
it is a very scientific methodology to how you're gonna classify risk.
You can't argue with the science. If you could change one thing about how commercial projects are built in the US today, commercial solar projects, what would it be?
Third-party EPC, most effective.
I 100% agree with that. All right, last few questions for you, David. When you and James Nagel first started connecting the dots between NEC 690.12 and these field failures, what was the moment you realized this was bigger than just a few isolated incidents?
Yeah, when you go from, again, just going back to the history, we've been doing root cause analysis on thermal events for a while, right? Once you start seeing a very clear trend, like, oh, another RSD fire. Oh, wait, another RSD fire. Wait, another RSD fire. At some point, it's pretty obvious something is going on.
Yeah.
And then you try to find, it's like, oh, is this one company having problems or is this multiple brands? And unfortunately, it has been a little bit of everything. There's different companies have different failure rates, and we've
Yeah.
seen more thermal events associated to one companies than others. But in the end, it feels that it's a deeper problem.
Yeah. Given that most thermal events are buried under NDAs and there's no national database, how confident are you that that number of 21 thermal events isn't actually higher? Like, what would it take to find out?
Oh, that's number is definitely, is probably a very small sample of the industry
Wow.
reflecting the industry. I guarantee you there are more. It's just
How
no
can we,
one,
how
no,
can we find out if there's more?
again, if you look at the way firefighter departments are tracking their data on incidents, usually they go through a process to associate the fire being started by the solar system or not. So that's as deep as you can go. So there's no component level fire root cause on any
Got it.
fire investigation. So fires in general associated to solar systems are tracked. What is not tracked is due to what.
Got
And
it.
then we have code cycles that, if you look at the data, it's like, now you have to kind of normalize that data. It's like, oh, how many RSD failures? RSD was added into the cycle 2017. Now it's complicated. That's part of the challenge.
Wow. So NEC 690.12 was written with genuinely good intentions, we believe. As someone who's kind of calling for it to now be reconsidered, how do you approach that conversation with NFPA code making panels without it feeling like an attack on the people who championed it?
I always say I'm component agnostic. I
Yeah.
care about like good components. I have no interest on any of the components out there. I root for anything that works reliably and safely
Yep.
for many years. The answers, I don't know what is, I want to bring this to the attention to the code making panel so they have the feedback loop.
Yep.
And to me, we should reconsider the way we're doing it.
Yeah.
If we don't know how to, sometimes it's wise to take a step back to take this next step forward.
Yep.
And if that means going back to no MLPs until we figure out a better way, that's great. If that means better testing standards for these devices, so be it. Like that's what we need to do. So I don't have a direction I want necessarily the code to go. I want them to understand that the consequences for the industry are real. And again, think about any of the really large companies out there deciding to shut down their sustainability programs and going public about it.
Wow.
Those will be terrible consequences for the industry.
Hugely. You put out reports pretty regularly. I know you just released this RSD report. Is your mind already thinking about the next report and like what data you might be chasing down? Are you already kind of thinking which angle you're going to go next?
Yeah, we're working on it. So it's coming. It's coming out.
I see the wry smile. You're like, I'm not going to give anything away.
Yeah, we're working on it. It's super interesting. Data nerd. We have so much data. It's like, what story can we tell? What is interesting within the data? So we're kind of always looking for a new angle. In our PV Health report from 2025 and 2024, we were trying to highlight the need for better standards, and we talked about the methodology for risk severity, as well as presented a bunch of data. On the 2025, we actually tried to give the angle of looking at the contractors and EPCs behind it and how they rank to each other and how, what is the industry in terms of quality? How do they see each other? We're gonna take a different angle for sure. On the next one, we'll have already a few ideas.
I'm looking forward to it. I love your reports every time they come out. So this show's called The Future Current. If you could, put on your prognosticator's cap and think like in the next 5-10 years in our industry, what do you think? What's a bold prediction you can make about where our industry will be in the next 5-10 years?
Yeah, I'm all about like solar and storage. I think it's just the way, whether we like it or not, that's the only solution at the moment that will help us bridge the gap that we're having with all the electrification revolution that is happening with data centers, AI, electric vehicles. I think solar and storage is the easiest way to tackle that problem.
Yeah. You mentioned earlier, we're at an event, we're at Solar Plaza Asset Management, and, the CEO of Solar Plaza, Edwin, opened today's show talking about the Netherlands, where they're based, and they can't add any more solar at this point without adding battery storage because otherwise it's just more negative pricing because of the issues, right? And so storage is sort of the solution to getting more solar on the grid.
Yeah, totally, 100%.
All right, so we talked about these great reports. If someone who's listening and watching the show wants to see these reports, where do they go to find these, and where do they go to find out more about SolarGrade and HelioVolta?
They can go to solargrade.io on HelioVolta.com.
Okay, and download the reports. They're publicly available, right?
Yep.
For anyone who's interested. Okay, amazing. David, CEO of HelioVolta and SolarGrade, and just shining a light on the industry that needs to be shown. So thank you so much for joining me today on the show. It's been a pleasure. Really appreciate it. And to my listeners, thanks for tuning in to an episode of The Future Current. I'll see you on the next one.